So this is live 2D compositional programming. I am Michael Homer. Before we go on, just note that this is all a live system you can run in your browser. You are able to go to that location, or you can follow the link on the Google Doc that's running and follow along with everything I'm doing here as well. So this system is a tool that I built originally for dealing with concatenative programs. If you were at Paint yesterday, you will have seen me talk about that part. But very, very briefly, and then we'll forget about it, a concatenative language is one where functions are automatically composed and arguments are passed implicitly. Most often, that is done with a stack. So this program up top here, 1, 2, 3, 4 mul swap, is saying, please push 1 to the stack, 2 to the stack, 3 to the stack, 4 to the stack, and then multiply by pulling 2 values off, multiplying them, and pushing the result back. Swap is going to take the top 2 things off the stack and interchange them. So we see that in our 2D version here, with 3 and 4 being laid out above our mul. Mul here, the darker ones are the functions. The light colored ones are our values that we're dealing with. And so we're able to see our values and our functions in here at the same time. We don't have to think about mentally simulating what the stack is doing, which is one of the reasons that these languages are sometimes thought to be write-only languages or incomprehensible, because you have to think about exactly what every single function that you deal with is doing. We can modify this as well. We have the ability to manipulate the system. I can just drag across and I can add these numbers together, and we can see that everything still works the same way. So 1 and 12 are above add, so add is taking in 2 arguments, 1 and 12, and producing 13. When I did that though, we'll notice that we no longer have across the top here this concatenative program that I was talking about to begin with. That's because when I made this change, I made the program no longer able to be represented in that concatenative style. I've used a value that wasn't on top of the stack. So I am not able to write that in a language that requires that all the arguments are on top of the stack. But everything still makes sense. Everything that we've been looking at in the grid here, with the functions laid out under their arguments, that still all works, but I don't have the concatenativity there. So this is a system that I built and then discovered that it did both more and less than what I wanted. It works quite well as a live system, and it works a little bit less well as a system for editing a concatenative program, because you can edit programs, you create your program, and then make it not be concatenative anymore. But I can still do all the things with it that I want to do with it. I can still change my values here, and everything will update live. I can still remove functions from it if I want to. I can still put in new stuff to it as I want to. I can still edit this program. Everything still makes sense in my live world. I'm just no longer going to think about making it be concatenative. I just want a purely compositional, data flow driven program that's going to show me exactly what I'm dealing with at all times and where all my values came from at all times. I just divided a couple of numbers there. That's divided, in this case, 15 by 2. That's the order that it wants them to be in. But there's not really any way for me to know, other than actually knowing, which way around those arguments go. So one thing they added to the system after deciding that the concatenative model didn't work so well is these kinds of little markers to say, I'm dealing with this function. I want to label which arguments are which and which outputs are which. My functions can have as many inputs as they like, as many outputs as they like. I might want to know which one they are. So put these little labels in. So you can see up there, there's dividend and divisor, giving us a quotient at the end. This is potentially useful. However, they are a little bit noisy. I can add another function here if I want to. You can see we end up now with 2 different labels for quotient being what it was called by the function that produced it, and minuend being what it was called by the function that is consuming it. I'm not sure whether these labels are actually useful or not. They're quite noisy, and I'd say the main piece of feedback I've had from people is I've never seen the word subtrahend before. If this is your day, that's what a subtrahend is. These take up a lot of room. They're not necessarily the most useful, but there are cases where they do probably make sense for us to deal with. So when we're seeing those on screen throughout the rest of it, it's possible that this is not a good feature in there, but it is going to be in the system that we see for the rest of this talk, so I want to introduce it now. So we have this system that is live editable. I've got these values all laid out just in little grid cells here. I want to be able to do more stuff with them. So I can deal with values that are not just numbers that we've seen so far. example, I could say I want to make a color in using HSL, and it gives me back this little light pink shade here. That's just a value, and I can show that directly within the program the same way that I show all of my other values. I can then, if I want to, say, I want to spread this out. And now I've made a little program that's going to convert between HSL and RGB and labels them for me. So perhaps these little labels are useful here in some cases, in other cases, not so much. I'm not really sure. Let's look some more at using these sort of higher level value types and how they can make our programs liver and easier for us to follow. So here I'm going to build up a program that's going to go off to Wikipedia, and it's going to pull in information from the Wikipedia page on Charles Dickens. Quickly show that. It just fetches everything in, brings it in as basically a record type. I'm going to get rid of that because that takes up too much space for me. And I only really care about the thumbnail in this case, so let's take the thumbnail out. I'm going to add in another literal value here, pick a color, and I'm going to pick, I don't know, purple. And I can combine these together as well. So I've got a program that is doing these kind of live manipulations of images of really any kind of type that I want to implement something that can render a value from. And I can update them just like I could before, and everything updates live as well. When I update the prerequisites, it updates the values I'm going to use later on. And I get live updates for everything here as well. So these are just relatively simplistic examples and copyright-free images that I'm allowed to use for this recording. And we are able to extend this system basically however we like to add any kind of rendering that makes sense in here. I talk in the essay a little bit about ways you could extend those values a little bit further to make them more interactive, but this version doesn't deal with that. And there are some complications that come from trying to make it work that way as well. Let's dive on to another example of doing that same kind of thing. Here, I just want to show off, if I just drag across, I select multiple arguments I want to use by dragging across them, and I pick up this draw on function. So here we can see I've actually added 4 labels to these 4 values here, lower, upper, X, and Y. This is a case where those labels are probably actually useful to me. They're actually telling me what these particular things are. Here I am taking in my 2 thumbnail images, scaling one down, and putting the author's picture over the bottom corner of the book cover. Without those labels, I had to guess which way round X and Y are, which one was on the bottom, which one was on top. Those labels are useful, but they seem like they're only useful if they are universal. And universal ones get quite noisy. So I'm not sure. I'm interested if you will have anything to comment on here. See, this one program actually does turn out still to be concatenative. I can come across here and it will highlight which bit is which here. So programs that are concatenative are relatively common. Programs that aren't concatenative are also relatively common. And at the moment, the system just shows you the concatenative version if it happens to be concatenative and hides that entirely if it isn't. It will show you how to go between one and the other if you want to, and I can also edit it live here if I want to. Change that to 70. And now move my image around, everything goes back in live as well. So, as well as dealing with these higher level value types, I also wanted to deal with functions that do a little bit more interesting stuff. So far, everything we've looked at has been just, here are some values, here's a function, and I get back a value definitely end of it. There's no looping, there is no recursion, and that is, to some extent, a design decision about how this is going to work. I decided I didn't want to have higher order functions because I'm not sure that actual users want to use those things. But I do want to have the ability to make those kinds of transformations that are actually commonly useful for people who are dealing with data in their world. So I also have the ability to define user-defined functions. Here I'm going to define a function that just adds 2 numbers together, put them at the bottom, and say, give me a new function. And I'm going to say add. Oops. Say add. There we go. This function just adds 2 numbers. I can try it out quickly, and it will add my 2 numbers together. It generates names for them from a list of adjectives and nouns just to make it easier. I'm going to pop over again to edit my function. Now I'm going to say I want to lift this function to a foldable. So now it's going to take that function, and rather than being a function that just takes in 2 ints and gives me back an int, it's now a function that takes in, say, a list of ints and an int, and gives me back the sum of all those values. Then pop across, say change squid. And now I've got the sum of all these values that I put in without having to write a loop without having to deal with higher order functions or anything like that. Similarly, I can make something that does a map operation as well. I can do this one. So I want to make a new function. Let's take out some of these. Make a new function. So make a new mappable from this. Let's do it with the short version. And I'm going to say we're going to convert them to strings and then double them up somehow. Make them a string. I'm going to dupe it. Get 2 copies from one, and concatenate them back together again. So this function takes in a list of integers, and gives me back a list of strings with each one of them doubled up. So I want to write code that deals with lists and collections of values, while I only write functions that deal with individual values or pairs of values and how to combine them together somehow. The idea behind this is that users who are dealing with this is mostly aimed for people who may want to process some data, but aren't necessarily programmers. They want to see what's going on. They want to have live affordances that show them what things they can do with the data right now. So when you select some values, you drag across. When you do that, you'll get a list of all the functions that can take those values. They can exploratorily go through their data, see what's available. They can make whatever changes they want to, and they will see live on screen whatever it is that's going on. They can back it out. They can make changes further up on the page, and they'll see whatever modifications they make as that goes. When I show this to people, I think a common thing that I get from people who are programming languages people is they really want first-class functions. They really want, in some cases, monads and monoids and stuff like that. I've been trying to avoid putting that kind of stuff in because I think that appeals to me and to us and not so much to the people who just want to process their data. We'll see how that actually turns out at the end of the day. It has been very popular as a suggestion every time someone sees the system so far. Let's look at a slightly more complicated function here that's going to deal with mapping some strings, folding some strings together. You can actually see something a little bit more dramatic going on. This one, add this in, and let's get rid of that. And now I've got a predefined function I already wrote here. This one shouldn't full screen this. This is going to take in a list of numbers and put twice those numbers joined together as a big string with ampersands between them. Here I can join that up and call my function, and the same thing happens. So I can build these up and I can try them out as individual items and then test them, then make them be a mappable, a foldable, whatever else, and have the outcome that I want directly testable as I go through. I mentioned earlier that this system is not concatenative, and that was a little bit of a lie. Very briefly, I want to circle back to exactly how this really is still a concatenative system. It's just that I said that these systems are mostly stack-based. This one turns out, accidentally, not on purpose, to be a queue-based system where everything runs crossways here and crossways here, and all these empty ones are the identity function. It runs left to right, top to bottom. As a queue, everything works out. I don't think that's useful as a way to think about it. It just happens to be true, and maybe someone here is going to tell me that's really useful, but I'm not really sold on that myself so far. There's more discussion of that in the essay as well. At that point, though, I might let people ask any questions that they have, or try it out and see what they can build themselves. All right.
Okay, thanks, Michael. We have time for a couple of questions. If not, I have a question. So as I was watching you demo this system, one thing that stood out to me was some similarities it may have with spreadsheets. Mm-hmm. Now, typically when I see people use spreadsheets, they have values that the data kind of flows from left to right, and here your data flows like top to bottom. That's kind of why I drew an analogy. I was wondering if you had thought about the analogy yourself, and if you had any thoughts about it.
Yeah, so actually this part of the system was inspired by a talk at Live 3 or 4 years ago from Hisham Muhammad, New Zealand, which was a spreadsheet-like system. I actually wanted it to go horizontally. That was my plan. I decided to implement it using an HTML table, and then discovered that using a vertical direction was significantly easier doing it that way, because I can just say this cell should be this many columns wide without actually adding thousands of TR elements to my page. So it became a vertical system at that point. My goal is to rebuild the renderer in something less silly, and then not have that problem anymore and let it go both ways. So I wanted it to be horizontal. It's currently vertical just because the implementation was significantly easier that way for me.
Thanks. Yeah. Okay, that'll be our last question for this talk.
So it seems kind of limited in scope if you're just providing like individual numbers. Do you have any means to do mass data input, such as importing CSVs or anything of that sort?
That is not implemented in the system, but basically that is why the maps and the folders and so on were in there. The things like the Wikipedia fetching function, those pull in record types. They have the ability to be a list of records to pull things out in a more structured way. That's basically what it's for, is to do mass data processing. But bringing in mass data and then processing it is harder to write in a demo, basically.
Okay, one more round of applause for Michael. Thank you.